So to test out that model, what we're going to do here in the next cell is basically load the model. So just like we saved the model, we can now load it in. So we're going to access that file and load the model into a variable called loaded model. And what we're going to do after that is basically score that model, this is basically doing the predictions. So we're going to give it, so we're actually going to score the model. So we're getting the coefficient of determination in this case to see how accurate the model is by getting all the X test values and the Y test values. So the inputs and the outputs, which are in the scoring dataset. So basically, remember the machine learning model was done on the training dataset. So we're basically scoring the training results on the test dataset. So we're trying to score the model to check how accurate it is. So again, just to summarize what we're doing in this cell, so we're getting that model into a variable, so which is in a file right now. So the file we saved in the previous cell. So we're loading that model into a variable, and then we're scoring it against the scoring datasets. So this will give us the coefficient of determination, basically. And so the closer you are to 1, the more accurate the model is. So in this case, it's around 0.9. So the model is pretty accurate. And what we're going to do next is just test that model, and we're going to show you how you can test it. So what we're going to test it on is just 2 values. Remember, the model accepts, the way we designed it is it accepts or it expects 2 inputs. So which are in this case temperature and wind speed, and it's going to return the active power. So this is just showing you a sample test of how you can test the model. So what we're adding here first is just an array with 2 values. One is a temperature and the next is wind speed. So we're giving it a temperature of 45 with a wind speed of 6.6. So that whole thing is our input, and we're calling the prediction on the regr_2 model, which is the loaded model. And then we're using a function .predict. So we're using the model to predict the output, which is in this case active power, based on the input we're sending, which is an array of 2 values with a temperature of 45 and a wind speed of 6.6. So if we run that, we get the result. So what this means is, based on the model we have created, if we pass to it, and again we're just doing a test here, if we pass to it a temperature of 45 degrees Fahrenheit with a wind speed of 6.6 meters per second, we're gonna get 318.57 kilowatts for the active power. So just to summarize this lesson, we have created a machine learning model. We actually created 2 models and chose one of them because it represents most of the data. So it can cover most of the data. Then we saved that model into a file so that we can call it later on. It becomes like a function you can call. And then we tested out that model. So we loaded that file in, and we checked its coefficient of determination, which was pretty good. It's around 0.9. And then we tested that model by sending an input air temperature and wind speed to it, and it returned to us the predicted active power. So in the next lesson, we're going to use this model we have created to send to it forecasted wind speed and air temperature from a weather service. We're going to use OpenWeatherMap, which has a free subscription. So we're going to retrieve the forecasted air temperature and wind speed for the next 5 days we're going to send those as inputs to this model, which we've already created, and get the forecasted active power for the next 5 days, and then send that back to OCS.